Let's take a look at three more examples related to thermal energy. Okay, so here's the first one. Medical device. Okay, so scalpel has been heated during medical sterilization. The device has a mass of 128 grams and is made of stainless steel. The specific heat capacity for steel is provided, so it's 420 joules per kilogram for every degree Celsius change. So if the temperature has increased by 120 Kelvin, then calculate the heat. Okay, so for this example, we can write down all the givens. Now, a heat, okay, so it's going to be heat is equal to always the mass, right, times the specific heat capacity times the change in temperature, right? So those are the things we need. Now, what is given here? Well, they do give us what the mass is. So mass is 125 grams. They give us what the specific heat capacity is. So that's 420, and that would be joules per, and this is per kilogram degree Celsius. And actually, I'm already noticing. So notice this one is grams, this one is kilograms. So I'm going to just make them consistent. So this one's going to be 1.25 kilograms. Okay, so just so that these two are aligned. And then finally, there's a change in temperature. Now, change in temperature, so please remember that 1 degree change, so for example, 1 degree change in temperature that you have is actually equivalent to 1 change in Kelvin. All right, so these are identical. So that means if they give us the actual, so within here, so if the change was 120 Kelvin, well, that equals the same thing, because notice in our specific heat capacity, it's per degree Celsius right there. So if you're going to write that in and make it consistent, so this is the same thing as a change of temperature of 120 degrees Celsius. All right, so now that we have all of these, then this becomes very simple because we can just substitute it in. All the units are aligned, so 1.25 multiplied by 420 and then multiplied by 120. So notice all of those units, okay, are aligned. So kilograms, so joules, kilogram, degrees Celsius, and then this is degrees Celsius. All right, so this is going to be in joules. If I take out calculator, I can put that in there and multiply all of them, and that's what I will get. So 6,300 joules. All right, so you can just double check if you want to have the same number of significant figures as maybe the lowest amount. The lowest amount is actually 2 anyways. Okay, so this works well. So that is the heat, okay? And that's all that you would have for this example. Here's the second example in this video. So it has been observed that 2.5 ounces, so it tells us that 1 ounce is 28.35 grams. So this is actually approximately, but it's pretty good to 2 decimal places, of silver. So the specific heat capacity of silver is 0.237, and notice it's joules per gram, okay, for every Kelvin change. So it has released 252 joules of heat. What was the temperature change of the substance? Okay, so let's give this a go. So what has been given in here? So again, this is the formula that we have, and we're just going to have to kind of be careful in terms of units. So first of all, what has been given? Well, we have the mass, and this is 2.5 ounces in here, which I'm going to convert right away to grams. So 1 ounce, so this is 28.35 grams, and that equals, so let's see what that will give me. 2.5 multiplied by 28.35. I am not going to round anything here. I'm going to just leave it as it is. I'll do the rounding at the end. So now I have the amount of grams, okay, of silver. The specific heat capacity is equal to 0.237. This is joules per gram Kelvin. Now notice here, so I have grams, and the specific heat capacity is per gram. So I can leave that. I don't have to change it to kilograms, because if I did, then I would have to change both this to kilograms, and then I would also have to change this to kilograms, right? So I would have to kind of be careful, multiply it by 1,000. So I'll just leave it because it's already consistent in the units of grams. Now, what else is given to me? So it tells me how much heat has been released. So that would be Q. So that's 252 joules, all right, of heat. 252 joules of heat. And so with respect to that, so this is actually fine. Okay, notice this is joules, so that's consistent. All right, so I don't really need anything else. I'm just missing the delta T. So if I'm going to go back in here, so let me substitute everything into the formula. So 252 joules is equal to the mass. I'm going to keep the mass as it is. That's in grams. Multiplied by, so it's going to be multiplied by 0.237. That's the specific heat capacity. And then times delta T. All right, so what does that tell me? So I'm going to take this on the left-hand side, and then I'll divide both sides by this, right? And then I'm going to isolate for my delta T. So that's going to be there. Okay, so let's try it. I'm going to do it all in one shot. So 252, that's on the left-hand side. And it will be divided by, okay, what I have on the right-hand side, which is 70.875 times 0.237 equals. So that change, so notice this is, well, there you go. Okay, so let's see, what was the lowest? Too significant. Okay, so I'll leave it to 15. So that's what we would have it. So this would have been 15, okay, Kelvin change, okay, in terms of temperature. Now, what was the temperature change of the substance? So there you have it. So they don't really ask for any specific unit, so I can leave it. But of course, this is equivalent to, if you wanted to go back to degrees Celsius, then you can. They're the same because the change in Kelvin is the same in degrees Celsius. And that is it, okay, so for this example. Here's the last example. So a surgery has been performed at room temperature of 72 degrees Fahrenheit. A stainless steel drill bit of 12 grams has been used, and it has been observed that 277.2 joules of heat has been absorbed by the drill bit. Okay. What was the final temperature of the drill bit in degrees Celsius? Okay, so the specific heat capacity is provided there. Okay, so let's write all of these things down. So what is given? So the given pieces of information. So this will relate back to this. Q is equal to, okay, MC delta T. Now, because they give us the initial temperature, so this, okay, this delta T, okay, that we find, we're gonna, so please remember, delta T is T final minus whatever T initial is, right? That's the change in between. So we're gonna try to find all of this information out. So a surgery has been performed at room temperature, right? So our room temperature, so our temperature T, so this is the initial temperature. This is not a change. It's in 72 degrees Fahrenheit, okay? So that's what I have. A stainless steel drill bit, and so that's my mass, is 12 grams, has been used. The amount of heat transferred, so Q, in this case, is 277.2 joules. So it's positive, so that means it's observing, it's absorbing, okay, energy, so it's going to increase its temperature as you're going up. Negative Q means that you're actually letting go of thermal energy, right? So you're kind of losing out that energy and it's being transferred out. So this is positive, has been absorbed, and it actually states that, okay, so it has been absorbed. What was the final temperature? All right, so okay, fine. They give us what the specific heat capacity is here, which is 420. I'm going to have to kind of play around because the units are not really aligning in here. So notice, well, first of all, this one's easy because I need kilograms. So I'm going to just change this to kilograms right away because specific heat capacity is per kilogram. This one is in joules, so that's fine. degrees Celsius. That's not fine. Okay, so I mean, I'm going to worry about that afterwards, but I know that this, okay, I'm going to eventually need to kind of worry about it and change it back to degrees Celsius. So first off, my first step, because I have mass, I have my heat, and I have my specific heat capacity, that means I can find out what the change in temperature was. So let's maybe do that first. All right, so we have 277.2 joules is equal to 0.012, that's the mass, times 420, that's the specific heat capacity, times the change in temperature. So the change in temperature is going to be the left-hand side again, so divided by all of this, right? So that's what I'm going to be worrying about there. So let's find out what this is. This is going to be in degrees Celsius. So 277.2 and then divided by 0.012 times, and this is 420. Okay, so this is 55 degrees Celsius temperature change. All right, so now step number 2, okay, will be that our change in temperature is equal to the final temperature minus my initial temperature. Now I have my initial, but I have it in Fahrenheit, right? So let's change that back. All right, so that's going to be this item right here. We want to be able to change this back, and for this, you know, we need to kind of recall what the formula is between degrees Celsius and also Fahrenheit. Okay, so let's bring that back, that formula. All right, so voila. Okay, so there it is. Okay, by magic. And of course, you can look that up in your formula sheets or something that you're using, and sometimes it's even given in the question. So it's not given in this one, so I just kind of brought it in back for you. So my temperature in Celsius is equal to, so this is 5/9. So my initial, so Fahrenheit, was 72. This is going to be 72 minus 32. So that bracket is easy because 72 minus 32, so that's going to be 40. All right. And now, okay, this is for my initial, right? So this is my initial temperature. Initial temperature. Now I'm going to change it back. And so for that, so this is going to be 5 times 40 divided by 9. All right, so it's 22.2. And now if you substitute it back into here, so the change was 55. Okay, this is my final. My initial is 22.2, etc. So if you bring it over to the other side, it's going to be an addition. So my answer plus the 55, and we have our answer, which is 77.2 degrees Celsius. So that is my final temperature. All right, so it has absorbed heat, and again, to two significant figures, it would have been just 77. All right, degrees Celsius as my final. And that is it. Okay, so that's all that you would have for this example. And that's it for this video. Okay, I hope that you found these examples useful. Bye, everyone.